Hey y'all, it's me again. Y'all, I am so sorry that I'm not there again today. I super apologize for missing so many days. Um, I would rather be there with you guys, I promise. But alas, uh, I am at a meeting tomorrow, and Miss Castile is going to be there, and she's rad. But I wanted to record just a quick video going over some stuff from the last module as well as the stuff from this module, all of which is about completing the square. Okay, I kind of ran out of room with the square there, but that's fine. Just pretend I didn't. Completing the square! Shblam, shblam. So, all we're trying to do here, y'all, is to write quadratic equations as perfect squares. So just in the same way that 25 is written as 5 times 5. That's what we're trying to do. We're going to say, oh, instead of writing this giant quadratic equation, I just want to write it as two things squared. Um, so, let's talk about some of the stuff out of the book. So I'm going to go back actually to module 2.4 and talk about some of the stuff out of there because we did module 2.3 together. So module 2.4 hits on some of that and then goes a little bit further. So let me pull up one of those problems real quick. Okay, so here we go. Sometimes a customer orders more than one quilt block of a given size. For instance, when a customer orders 4 blocks of the basic size, the customer service representatives write up an order for a of x equals 4x squared. So a of x is the area, and it's just 4 times x squared. Model this area expression with a diagram. So y'all, this literally just means 4 blocks of the basic size. So that means 1, 2, 3, 4, just like that. And then I'm going to say the sides of each one of these are x by x, x by x, x by x, and x by x, which means that the area is going to be x times x, which is x squared. So all of these blocks added together are just going to be x squared. Another way you might show this is like this, with all 4 of the blocks together. That also is totes fine. So this here would be x, that would be x, x times x. So each one of these would still be x squared, x squared, x squared, x squared, for a total area of 4x squared. Okay, let's get on down to this next question. I'm going to move some things up so we have more room for this. Okay, so here we go. So one of the customer service representatives finds an envelope that contains the blocks pictured below. Write the order that shows two equivalent equations for the area of the blocks. So again, y'all, we have the big square, and each one of these sides is going to be x. So when we find the area of just this square, it's just going to be length times width, which is x times x. So the inside area of this puppy is going to be x squared, right? Same thing over here. This is x times x. So this guy is going to be x squared. Then we have added 3 inches. So this is plus 3 inches here. So if we know that this length going along here is x, and we know that this length is 3 inches, because it said we were adding 3 right here, then what's x times 3 for the area of this section right here? If you said 3x, you are exactly correct. You are exactly correct. I was going to say correct, and then it ended with right. Sorry. You're exactly right. Now, let's go to the top. It's going to be the same thing up here. I added 3, so same idea here. This side is x, because this side is x, which means this has got to be x. And then I added 3 right here, so 3 times x means the area of that section in there is going to be equal to 3x. Now, all we're left with is this bit over here, and this is the part we were talking about that completes the square. So this makes the square nice and squarey. So how many units did I have to add here? I have 3 here, and then I have 3 here. So 3 times 3 is going to be 9, right? So that means that for this particular square right here, the area of it is x squared plus this section right here, 3x, plus this section right here, 3x, plus this section right here, which is 9. So that means I'm going to write it all out pretty fancy here. So the area of x for this one block is going to be x squared plus 3x plus 3x plus 9. Let's combine our like terms. So that means it's going to be 6x plus 9 because I have 6 total x's if I add those together. Now, it is asking me for the area of both blocks together. So this, my friends, is only the area for one block. So I want the area for 2 blocks. So if I know that this is the area for 1 right here, how can I change that to the area for 2? This is going to be the easiest question you have all day. If we want to take 1 and make it into 2, we just multiply everything by 2. So I'm going to do 2 times x squared plus 6x plus 9, which means, guys, what are we about to do? We're about to distribute. That was an air horn. That was an air horn noise right there. So for 2 blocks, it's going to be 2x squared plus 12x plus 18. Oops, not 8. I just wrote 8. 18. There we go. Okay, shablam. So that is one expression for the area of these blocks. Now, the other thing that we can think about when we're trying to find the area, what we did is we just added up all of these individual areas inside. But if it's a whole block, remember that we find the area of a block using length times width. Well, y'all, check it out. Here's the length. Here's the width. This side is x plus 3. This side is x plus 3. So again, for one of these squares, the area is going to be just x plus 3 times x plus 3. And what's a nice mathy way to write x plus 3 times x plus 3? Y'all, let's just write it as x plus 3 squared. Bow, 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 bow. So again, if I want to change that to for both blocks, for 2 blocks, I'm just going to multiply that by 2. So a of x equals 2 times x plus 3 squared. So these two representations down here represent the area of both of these blocks combined. And these guys are just for 1 right here. So hopefully the area model makes sense. I really like it. It makes it easy to visualize for me because I'm like, oh, I'm completing the square. So hopefully, fingers crossed, that makes sense to you. So go ahead and pause this, check back over your stuff, make sure that you got this all right, and then I'm going to go on to number 3. Okay, guys, here we are at number 3 and number 4. I'm just going to do these real quick, walk you through them. If you know how to do this, go ahead and fast forward a few minutes until we get to the next bit, which is a little bit harder. But I just want to make sure that y'all can do these. So I am looking for what equations for the area could customer service write if they received an order for 2 blocks that are squares and have both dimensions increased by 1 inch in comparison to the basic block. Write the area equations in 2 equivalent forms. So I have 2 blocks. So let me start with my 2 blocks right here. Here's 1 block. Here's 2 blocks. And each one of those has the dimensions increased by 1 inch. So here's plus 1 on this side, plus 1 on this side. So here's my x, plus 1. Here's my x, plus 1. And I'm going to do this on this block over here. Boop, 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 boop. Boop, 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 boop. So here's my x, there's my plus 1 on that side, plus 1 on this side. So what do I need to complete the square, to make the square squarey? If you said, I'm going to zoom in right here, if you said, add a square right there, Miss Ray, then you were absolutely correct. I'm going to add a square right yonder, which means I need to do it over here on the other side as well. Add a little square right there, thank you. So now let's look at the area. So this guy is going to be x times x, which is x squared, same as over here. Then this is just going to be 1x up here, 1x right here, same as over here. And then this little guy is just going to be 1 times 1, so it's just going to be 1. Shablam. Okay, so let's talk about what the formula would be. There are two ways to write the formula. Remember, we're going to write both. So the first way I'm thinking of is the first way we did on that last problem, which is just adding up all of the areas inside. So I have x squared right here, except I have two of them, so 2x squareds, because I'm doing both. So that means 2x squared. Wait, I gotta write my area is 2x squareds. Then I have 1, 2, 3, 4 x's. So plus 4x. And then I have 1, 2 of those guys. So plus 2. Boom. That's one equation. The other way to think about this is just to look at the sides. Remember, I've got length times width for my square. So this is x plus 1 on this side, x plus 1 on this side. And I have two of those. So the other one is just going to be a of x equals 2 times x plus 1 squared. Boom. Okay, I'm just going to put the other one up and let you look at it, but hopefully that makes some sense. Okay, it looks a little messy, but this is what I got for the next one. So check this out. So 3 blocks, 1, 2, 3. Both dimensions were increased by 2 inches, so here's my plus 2 on each side, and I did that for all 3 of them. And then I completed the square with 4 blocks up here in the corner for each one. So I wrote my 2 equations over here. The first one, which is 3x squareds, and then, oh, what is that? Hang on, I've got to erase. Hang on, I don't know why I put a squared there. Ignore that. So I had 3x squareds, and then 2x is here, 2x is here, 2 here, 2 here, 2 here, 2 here. So altogether, that's 12 x's, and then 4, 4, 4, altogether that's 12. So that's one way to write the area. The other way is to take the length and the width. So x plus 2 times x plus 2 is x plus 2 squared. And there are 3 of them, so just multiply it by 3. Donezo! Okay, let's go to number 5, which gets a little cray. It's going to be great. If you know how to do this, great. Skip the rest of the vid. No probs. If you don't know how to do this, if you're still standing on shaky ground, check it out. Okay, guys, so here's number 5. Again, this is 2.4, number 5. Miss Castile already went over this, so if you're feeling all right with this, you don't have to watch this. This is just if you are having difficulty understanding or just need a little extra guidance. So, number 5, Clementine is at it again. Crazy Clementine. When is that dog going to learn not to chew up the orders? She also no, I'm not going to read that. Y'all, here are some of the orders that have been chewed up. So they're missing the last term. Good thing Optima knows a little bit of algebra so she can figure it out. So we're going to help her out by completing each of the following expressions for the area so that they described a perfect square. So remember, we're just completing the square. So this first one starts with a 2x squared. So that means that we are starting with 2 blocks. So bum bum, bum bum bum. Then it says we have 8 x's. So if we have 2 blocks, we're going to split those 8 x's over the 2 blocks. So how many x's does each block have? If you were saying 4 to me, you are correct. So let me draw those little x's. So there's going to be 2 here. There's going to be 2 here. Pretend those are straight. Oh, golly, I don't work in a quilt shop. I'm so sorry. Okay, so here is my x squared, Here is the 2x, 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 2x. Okay, so we're completing the square. So how many need to go up here to complete the square, right yonder? If you are saying 4 to me again, why did that come out blue? I don't want that to be blue. Let's go back to black. Okay, so 4 goes in each one of those. So 4, 4. So what term goes right here to complete the square? That would be 4 here, for a total of 8. Shablam. Okay. Now, the other way you could think about it, if you don't want to draw all of the square business, I'm going to zoom in on this real quick, is we could just say oh, we're talking about 2 of these blocks. So I'm going to divide it by 2. Get the 2 out of there. So I know that I'm only talking about 1 block. So if I take the 2 out of there, 2 times what gave me x squared? That was 2 times x squared. Then 2 times what gave me 8x? That was 4x. So that means I knew that each block, there were 2 of them, but each one block started with x squared plus 4x. And then I want to fill in that blank right there to make the perfect square. So remember, we talked about this c right here. The way that we find that is we take the b term, which is this guy right here. We take that b term, divide it by 2, so b divided by 2, and then we square it. So in this case, it would be 4 divided by 2 squared. Y'all, what's 4 divided by 2? It is 2. What's 2 squared? 2 squared is 4. So that means that the number that goes in there is 4. And then to find out what the overall number is, we just multiply that 2 back through, which turns into 2x squared plus 8x plus 8. So look at that, hot dog. We got the same answer both times. So either one of those ways works. So let's do this next one. And I tell you what, I'm going to do the algebra way first with the equation, and then we'll draw the blocks second to see if it matches up. So I'm going to take this 3. That means I had 3 squares. So I'm going to divide this by 3 because I only want to deal with 1 square at a time. So I'm going to take the 3 out, and that's going to be 3 times x squared plus 3 times what would give me 24? That would be 8x. And then I need to figure out what goes in this spot right here. So that is going to be 8 divided by 2. And then I'm going to square it. So what's 8 divided by 2? That is 4. So 4 squared, that is 16. So 16 is the number that goes in there. And then we're going to multiply that 3 back out to find out what goes in the original order. So 3 times x squared is 3x squared, 24x, and 3 times 16. I think I don't have a calculator, so I'm totes guessing, guys, but I think that's 48, maybe 48. So I'm going to go ahead and say that my final answer up here is 48 to complete that order. Now, let's go draw some blocks and see if we get the same response. So I've got 3 blocks. So here's 1, 2, 3. And each one of those is x squared, x squared, x squared. Now I have a total of 24 x's divided into 3. That means that's 8 x's for each one of these. So if it's 8 x's here, that means 4 on top, 4 on the side. So here we go. 1, 2, 3, 4, 1, 2, 3, 4. Again, just pretend those are straight, y'all. I'm so sorry. Again, I'm not a quilt maker, I'm a mathematician. There are reasons for this. 3, 4. Okay, so for each one of these guys, I need to put some numbers here to complete that square. How many numbers do I need to make this turn into a nice squarey square? If I extend all of those guys, it goes like that, and then shazam! Hey, look at that, I added 16. So, y'all, holy cow, this is totally gonna work. Math is so amazing. So if I do this every single time, I've got 16 here, and 16 on the first one. So how many did I have to add? 16 plus 16 plus 16, which is in fact 48. Okay, so the area method works just as well as the equation method. So now I'm going to flip on over to the next bit, which is slightly trickier. So let's go. Let's see what we can do. So here we have a real mess, according to Optima here. We received an order for an area, 2x squared plus 12x plus 13. Unlucky for some. So we're going to use the tiles here to figure out an equivalent expression for the area. So let's start making our squares. So we have 2 big squares right there. So I've taken care of that one, I've taken care of that one. And then I have 12 of these guys right here. So if there are 12 here, that means they're going to be 6 for this one and 6 for this one. So that means 3 on top, 3 on the side, 3 on top, 3 on the side. So let me do that real quick. So here's 1, 2, 3 on top, and then 1, 2, 3 on the side, and then we're going to do that over here too. Oh my god. It looks like a sad stack of waffles, really. I gotta do that one again. That was terrible. Let's do that. Here we go. Okay. Okay, so now we've used all of those. So I'm going to check those off. So now we have 13 of these squares. So how many squares need to go here to complete the square, to make it all nice and squarey? If you are saying 9, you are correct. There should be 9 squares here. So 1, 2, 3, 4, 5, 6, 7, 8, 9 of those squares are taken care of. Now, here's where it gets a little awkward, y'all. There are only 4 squares left, and I need 9 here to make a complete square. So let me just go ahead and put on my 4 squares. 1, 2, 3, 4. So how many squares am I missing? How many blocks are missing here to make this a perfect square? I'm going to put the missing blocks in a different color. There's 1, 2, 3, 4, 5. So these are missing. So that means we're looking, remember, for an equivalent expression for the area. So we're looking for an equation that would match this. So, whoa, I can do 2 lightsabers? Did you, wait, there, look at that. Wom, 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 wom. Okay, sorry, I digress. I just didn't know I could do that, y'all. So this means that to find the equivalent expression, this is x plus 3. This is x plus 3. Samesies over here. X plus 3, x plus 3. So a quick way that I could say to find the area of both of these would be 2 times x plus 3 squared, right? Because there are 2 blocks. They're each x plus 3. But I have 1, 2, 3, 4, 5 blocks missing here. So what I'm going to say is it's going to just be x plus 3 squared minus 5. So I'm subtracting 5. So this, y'all, right here, would be an equivalent expression to this right up here. If we multiplied all this out, if we squared this and did our foiling, our distributing and everything, we would get the same equation back up here. This is called, oh, no, I need a marker. This is called vertex form. Vertex form. This is going to come in real handy because remember, this will tell us when we're graphing this, we're shifting left 3 units, we're shifting down 5 units. This is what we're going to be doing in our next unit where you're working on 2.5 today. Okay, head on over to number 7 if you haven't done that one already. I'm just going to put up the key to it on the next slide, and we'll go from there. Okay, guys, so I went ahead and drew my boxes down here with the information they gave me. They gave me 3 boxes, so I drew 3 boxes. They gave me 6 of these long things, so I did 1, 2, 3, 4, 5, 6. I split them up for each one, and then to complete the square, I put 1 block on each of these. So let's check off what we have used. I have used my 3 blocks, my big blocks. I have used all 6 of my long guys, and I have used 3 of the tiny blocks. Now, here's the problem. I have some extra tiny blocks left over. These are all, this is awkward. They're all left over. So I have 1, 2, 3, 4, 5, 6, 7 extra blocks. So our equivalent expression here is going to be, if each one of these is x plus 1 by x plus 1, that means that the area, so a of x is, there are 3 of them, so 3 times x plus 1 squared. And then to deal with these 7 extras, I'm just going to say plus 7 extras right there. So this is the equivalent expression to the other area. Oh, they don't give us that. We're supposed to write 2 equivalent equations. Well, y'all, the other one's going to be easy. because we can just look at our areas and add them together. This is x squared. This is x squared. This is x squared because it's x times x, right? X times x. And then each one of these is going to be x times 1. So each one of those puppies is just going to be 1x. So I can put all those in. And then each one of these guys, where'd I go? Where's my thing? Each one of these guys is just 1, which I have 7 of up here. I don't even have to label this down here. I could just look at these up here and see what I have. Oh my God, I keep forgetting about the 2 lightsabers. I'm trying to zoom out. And it's all like lightsaber, lightsaber, lightsaber. So let me move this right over here. Yeah. And then I'm going to write this in another color. And I'm going to say the other possible way to write the area is I have 3 times x. Oops, no, not times x. 3x squared, because I have 3x squareds up there. 1, 2, 3, 4, 5, 6 x's. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 little 1 units. So this would be the other way to write this. Y'all, these 2 equations are equal to each other. So these are the 2 ways. This is standard form right here, standard form. And then this puppy up here is vertex form. So if you know how to write these, you are in good shape. All right, last thing I'm going to do for this video is show you the answers to the next page, number 8. If you have not done those yet, go through them and do what you can do, then come back and check. You can also just look at the key on Canvas if you click on your period resources, and then look at the worked out packet. The key is on there too, so if you just want to breeze past this and look at that, you can do that. Or just sit tight and the key is coming up next. Remember, pause it, you try it first, because you are good at math, and then come back and look at it. Okay. So here we go. Hopefully you have tried this already. What we're going to do is we are trying to figure out, are these expressions perfect squares? And if they aren't perfect squares, we're going to show how the perfect square can be adjusted to be the given expression. Okay, so, like I said, I'm just going to put up the answers here. You should try these. If you haven't tried them, try this out. I'm going to do one at a time, and then you can pause it so you can see what you're doing. Okay, so here we go. I'm going to start on the first one. Zoom, 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 zoom. So if this was a perfect square, it would be x squared plus 6x plus, I don't know, what goes here? This would be 6 divided by 2 and then squared. So that would be 3 squared, which is 9. So that should be 9. Ooh, this is not equal to 9. This guy right here, not 9. No. So how can I adjust the perfect square that I got to make it equal to 9? So basically, my question is, how do I get from 9 to 13? What do I need to do to 9 to get up to 13? I just need to add 4. So now I have adjusted that perfect square to be equivalent to the original expression. Donezo. If you wanted to write that in vertex form, it would look like this. X plus 3 boop-a-doop-a-doop, squared, and then plus 4. Because this part is equal to this part, and then we have the plus 4 on the end, which is right there, plus 4 on the end. Okay? All right. Go try number B. Letter B. Go try B. Okay, so when I do this one, huzzah! Look at this. I took the B, I divided it by 2, and I squared it, and I got 16, which is the same, which means, y'all, this one is, in fact, a perfect square. So I don't have to adjust this one. Okay, I hope you got the idea. I'm going to zoom out to right here, right there. I'm going to let you do the rest of these. I'm going to put up the key here in about 5 seconds. So if you want to try them, and then wait 5 seconds, and the key will show up. Okay, here is the key. So hopefully you were able to at least get number C without too much help. Now, when we get to D, E, and F, we have the issue of the coefficient out front being something besides 1, which makes things just a little bit more complex. Not very much complex. The first thing you need to do with those is divide that coefficient out. So remember, just like we were talking about earlier, getting this down to 1 square instead of 2 squares, so just dividing everything out. Then you can complete that square inside there and just adjust it. So here, I'm doing the exact same thing that I was doing up here. What do I need to do to this 4 to get it up to 7? I need to add 3. Boom. So this is my adjusted square in vertex form. That would be 2, and then this bit right here, let me get a highlighter. This part right here is the same bit as this. And then this plus 3 at the end becomes a plus 6. Does anybody know why that plus 3 becomes a plus 6? What happens there? Anybody know? There's this 2 up front, so it's going to be 2 times 3. That's what goes outside the parentheses right there. So 2 times 3. So those 2's, those guys in the front, we can make things a little complex. We are going to be doing a whole lot more practicing with that in Module 2.5. Also in the set at the end of this. So here's what I would like for you to do. Go check out the Canvas. Look in your period of resources. It's like second period resources or sixth period resources, whatever class you're in. And then look at the worked out book. And the key to the set, actually to the Ready, Set, and Go are going to be on there. So check that out. See if you understand this. And if you don't, we'll practice it next class. I will be in class on Monday, Tuesday, whatever the next day is I have you guys. I will be there, I promise. And we will hop to it. So if you have specific questions, y'all, please send me an email. Take a picture of your work and just be like, Miss Wright, I don't get this. Send me an email, and we'll work it out. Okay, y'all have a really good weekend, and I will see you next week. And always remember, you're good at math. Okay, bye.